So in this video, we want to talk about solving linear equations, but with context or in context. So remember that what that means is that there's going to be some kind of wording in that, all right? And so, a lot of people say word problems or application problems, all right? Now, one key thing to get out of this is that we've already done most of this, okay? We derived equations. We just didn't solve, okay? And so a lot of this we already know how to do. We just need to add in the layer of actually solving equations. So in a sense, this won't be anything new except for adding in that layer of actually going through and solving. So that's some good news. All right, and just to show you that we've already been through this, we've done math translation. So here's going to be a couple examples we'll do. We'll translate the sentence into an equation. That's the part we've already done, and then we'll actually solve the equation. Okay, and so we look at this sentence right here. The sum of twice a number and 5 is 17. All right, and so you got to know these key words. Sum, that means plus. All right, so we're adding two things. And remember, the two things we're adding are separated by the and. So we have twice a number and 5. And so we're adding 5. And now just remember, twice a number. Some people are still having trouble with that. That's multiplying by 2, not raising to the second power. Those are very different things. And so we have 2x plus 5. And then just remember this word is translates to equals. So equals and then 17. Okay, now we stopped there before, but now we know how to solve this. And so now we need to isolate x, so we want to get our numbers over on the right side. So I would subtract 5 from both sides, like that. And so I get 2x is equal to 12. And then if I go and isolate the variable, I would divide by 2. And so I get x is equal to 6. All right, so there's our first example. So here's another one. 8 less than 5 times the number, 8 less than 5 times the number is the product of the number and 3. Okay, now this one's a little bit more complicated, so I'll break it down. The key one thing, especially for more complicated ones, and if you know that you're going to have an equation, look for the equal sign. So if you notice, it's right here with the is. All right, and so that helps you break down the two sides of the equation. The first part is here, and I don't think that's showing up very well. I'm going to do it in blue. So there's first part, and then we have our is, so there's going to be my equals, and then the second part will be right here. All right, and then what that does is that helps you. Now we can just translate the two blue parts and put an equal sign in the middle of them. Okay, and so we have our equal sign. All right, now that first part you got to be careful of because of that less than. All right, it is obvious that that's a subtraction, or fairly obvious that's a subtraction, but you got to be really careful whenever you're subtracting or dividing to make sure you get it in the right order. And so remember that phrase less than, that means you take 5 times the number and then you subtract 8 from it. All right, and so we got 5 times the number, that's 5x, minus 8. All right, like that. And so we've been through that before, but just to remind you. And this one's a little easier. Over on the right side, the product of the number and 3. You just got to remember what that key word is, product. That means to multiply. So we have our number and we're multiplying it by 3. If you wanted to directly write it, you could write it as x times 3. Okay, but just remember that commutative property. The commutative property says it doesn't matter what order you multiply things in, so I could just as easily write that as 3x. Okay, so there's the translation part. Now we need to solve. There's different ways to solve this. Some people would move the variables over to the right side. I'm going to move them to the left side, though. And so I'm going to subtract 3x from both sides. This is mostly just to point out something here. Okay. And so 5x minus 3x is 2x minus 8. Well, what's left over here on the right side? 3x minus 3x. There's usually other stuff in my expression over here. So I'll just not write this. But remember, the reason we don't write it is because that is 0. So don't let that throw you. If there's nothing left on a side, then that's just equal to 0. All right, and I can still keep isolating for x. I would add 8 to both sides. All right, and I get 2x is equal to 8. All right, and then to isolate x, I would divide by 2, and so I get x is equal to 4. All right? All right, and here's one with fractions. There's a couple things to point out with this example, okay? But first of all, reading it, 2/3 of a number increased by 1 is 2 and 5/6, okay? And so you might want to locate your equal sign first. And so our equal sign is at the is, so there's our equal sign. Now the two sides are a little bit simpler in this one, especially the right side, okay? And so whatever we get over on the left side, we know that this is going to equal to 2 and 5/6. All right. So now we got 2/3 of a number, and so some of you are still having trouble with that. Of means multiply, not divide. Okay. It's a special term that applies whenever you're multiplying by fractions or decimals. We'll see later. All right. Especially whenever they're expressed as percentages, but we'll worry about that later. Okay. So we got 2/3 of a number. That means 2/3 times x. Okay, and then increased by 1. All right, so we're going to add 1. So there's our equation. So that's the first thing I wanted to point out with this. You got to remember that of means multiply whenever you're translating. Okay, the second thing to point out is notice that I have this mixed fraction, but I'm going to have to be operating on it, doing multiplications and divisions and so on. And so I want to get that in improper form to work with it. All right, and so the next thing I want to do is convert that 2 and 5/6 to improper form. That's going to be 17 over 6. Okay, like that. So now we have an equation with fractions. All right, and so you can just solve this normally. You could subtract 1 and then divide by 2/3 if you're good with your fractions, or you can clear your fractions. There's one thing I need to point out here, and it has to do with this as opposed to the way some books write, okay? And so some people write 2/3 times x. The thing is, all we're doing is looking at this part right here for a moment, okay? You can think about x as being like a whole number, so you could think about it as being x over 1, and then you would multiply straight across. And so you get 2x over 3 plus 1 is equal to 17/6, okay? That's up to you how you want to handle it. Just some people have trouble clearing the fractions whenever it's written this way. They'll get confused. And so just remember, if you have 2/3 times x, that's the same as putting the x in the top of the fraction or in the numerator of the fraction. Okay, I'm just going to remind you on clearing some fractions here. Like I say, you could just go from here. If you're good with your fraction operations, you could go from here. I'm sorry, we need to, let me write it over here. So the way we started out, you just need that mixed fraction in improper form as well. Okay, so you could just start off subtracting 1 from both sides, and then you'll end up dividing by 2/3 to get x. That's perfectly fine. Or we can clear the fractions. So we need our common denominator here. Well, first of all, I need to write that 1 as a fraction. Okay, so you could get a common denominator. The basic common denominator is multiply them together. Okay, which would be 18. And you can do it that way. Just realize especially this number over here is going to become pretty darn big whenever you convert. All right, and remember what I pointed out in the last video. Here my denominators are 3, 1, and 6. And see, 3 divides into 6, and 1 divides into 6. So there's actually a smaller common denominator. The LCD would be 6. Okay, you don't have to catch that. You can you can get this problem solved if you used 18. But often it's nice to realize that there's a lower common denominator there, especially when all the denominators divide evenly into one of the others. Okay, so anyway, we're going to convert where each one of our denominators is 6. Okay, so we're going to end up wanting each one of these things over 6. Okay, now first of all, realize a shortcut here. Over on the right side, this one already is over 6. So there's nothing to do with that one. Okay, so that's a nice shortcut there. And so here we have 2x over 3, but I want its denominator to end up being 6. So what do I need to multiply this 3 by? 2 in the top and bottom. Okay, like that. All right, and just remember from our last video My numerator here is 2x times 2, but I can multiply those two 2's because of the commutative property. And so this ends up being 4x. Okay? And then in my second one, I have 1 over 1, but I want its denominator to become 6. All right, so what do I multiply top and bottom by here? 6 over 6, right? All right, and so that the second numerator becomes 6. And so remember what we mentioned last lecture. As long as all of the denominators are the same, and they are, 6, 6, and 6, then I can just cross them out with that, and look what I have left. Just 4x plus 6 is equal to 17. All right? And so now I need to isolate x, so I would subtract 6 from both sides. And so I have 4x is equal to 11. All right, and then I would isolate x, so I divide by 4, and I get x is equal to 11/4. Now, why would I claim that this isn't really the form we want to answer this in, though? And it's because we always want to answer in the form that a problem comes. And notice that the problem was given in mixed form. So I would actually want to convert that to improper form. Mixed form, geez. All right, so that's the way we would want to answer that question. Okay, and so now we're just ready to talk about problems that actually have context or real-world context. And so this is what people usually think about as word problems. And people just have a natural aversion to them, so try to avoid that and just try to make them a process and approach them the same way every time. So if you remember back when we were first learning to translate, we had two different situations. And the first one was where the equation is given. So let me write an example for you here. All right, so here's an example. You might want to pause and read over this, try to absorb it. I purposely made it kind of complicated so that we can end up seeing a basic concept. And that's the key thing, is try not to let yourself get overwhelmed by word problems. And I'll point out some key things that makes it a lot simpler. Okay, but the idea here is when a store purchases a product for P dollars, so notice the units there are dollars, the price at which they will sell it, S, is calculated using this formula. Okay, if a product at the store is being sold for $145, how much did the store purchase it for? Okay, so this sounds pretty complicated, and there's all these weird variables and wording and so on. But the key thing is right here. All right, you're given the equation that people use, the store is using. So we're actually given the equation, okay? And whenever you're given the equation, try not to bog yourself down trying to figure out where that formula comes from or what it's saying. Just take it as given. But the key thing is to understand what these two variables represent. Okay, so you might want to look back through here. But what does P represent? Here's where it talks about P when the store purchases a product. Okay, so this is P is how much the store paid for it, and I'll call that the purchase price. Okay, so and if you're understanding what's going on, a store, a retail store, buys the product for so much. Think about an appliance store if you need to. All right, they buy a refrigerator for so much, but they need to make a profit, so they're going to sell it for more than they paid for it. Okay, and so then what does this variable S represent? We come back up here, S, the price at which they sell it, okay? And so S is going to be how much they sell it for. All right, so that's the key thing. Whenever an equation is given to you, you just lock in on what those variables represent. All right, and the next thing is you're going to be given something in the wording. If a product at the store is being sold for $145, okay? And so also there's something that's equal to $145, all right? Well, what equals $145? That's how much they're selling it for, okay? So which of those two variables is the 145? It's S, okay? And so we're given that S is equal to 145. And then what is the question asking? How much did the store purchase it for? All right, and so which variable are we trying to find here? We're trying to find the other variable, P. Okay, and so now we want to fill numbers in and solve. Okay, I don't always like to do this, but I'm just going to move this up like that. Okay, and so the idea here is now we have everything set up, and so S is equal to 100 plus 0.75p. Okay, but what are we given? We're given that S is equal to 145. All right. All right, and so now we have an equation that we need to solve for P. So we need to isolate P. Notice that the only place that P shows up is over on this right side. So I want to keep my variable over on the right, so that means I want to move my numbers to the left. And so I need to move this 100 over. And since it's a positive 100, I would need to subtract it over. Okay, like that. And so 145 minus 100 is 45, and then equals 0.75p. All right. Now, how do we isolate p? We divide by 0.75 or 0.75. If that bugs you that I dropped it. Now, you probably don't know what that is, and so you just type that in on your calculator. That's what I'm doing right now. I'm just doing 45 divided by 0.75, and it gives me 60. Okay, so I end up getting p equals 60. Now, another important thing here is we don't want to stop there. Okay, this problem had wording, so technically we should answer in words. But also a very important part is to include what are called the units, and that's what this $60 represents. And so that's the purchase price. And if you notice up at the top, I can't scroll it back down, but everything was in dollars here. Okay, and so at the very least, include units, but technically we would say the store purchased the item for $60. Okay. That's the best way to, or one of the best ways. There's other wording you might not word it exactly the way I did. Key thing is though, include units, and then just answer it in a short sentence, and you'll be fine. Okay, so remember there's this other layer that's harder and deeper, where we're given information and we need to translate to get an equation. And this is a harder part, all right? So you might want to pause and read through this. I'm just going to go through it quickly. But so we're looking at this situation. The amount that I usually pay at a restaurant is the bill increased by 1/5 of the bill, all right? And so what we're going to do is we're going to identify the variables and give them letter names. And then we're going to translate to get an equation relating the variables. And then we're going to actually answer a question that's going to require solving. If I tell you I paid $36 at a restaurant, how much was the bill? Okay, and so we just take it one step at a time. All right, and Part A is a very important step. A lot of people skip over this, and that's a weird thing about our brains, especially with word problems. We just want to get right down and solve the problem. And the key thing about word problems, especially if you feel like you're not very good at them or they give you a lot of trouble, is slow down and just take it a step at a time. And in general problem solving, the first thing you want to do is figure out what things are variable. So remember, these are things that can change. And even from this little bit of wording right here, there's two things that can change. All right? We're talking about the amount that I pay, but that's affected by whatever the bill is. So those are actually my two variables here. So you might want to use B for the bill. Okay, and a good higher level thing to do is always include the units, even when you're defining your variables. Okay, and let's see the amount that I pay, so let's use P for that. Okay, so this will be the amount paid. All right, and that'll be in dollars too. Okay. Like that. And be aware, we don't always have the same units, just my two examples that I've done did. Okay, so now for part B, okay, let's write out what that says, but I'm going to abbreviate a little bit. The amount paid is the bill increased by, remember that's plus, so plus 1/5 of the bill. Okay. Like that, and so now we're ready to translate that, and so we can spot the equation part, or the equal sign. It's right there, that's the is, and so here's my two sides of my equation in words, so I just need to translate each one. Okay, the amount paid all right? That's not known, but we have a variable to represent that, and that's the power of variables. We can use symbols or letters to represent things that we don't know. And so the amount paid is P, and then there's my equal sign. And same thing here is the bill. We don't know what the bill is, but we have a letter to represent it, okay? Plus 1/5 of the bill. So remember, of means multiply, so 1/5 B, okay? Like that. And then from what I told you before, remember we can think about this as being B over 1 and multiply them. And so we could just as easily write this as P is equal to B plus B over 5. Okay, so now we're ready to answer part C. Okay, and so part C is saying I paid $36, and I'm asking how much was the bill. Right? Like that. Well, the amount I paid is which variable? That's P. Okay, so I paid 36, and then now what is this telling me to do? It's telling me to find the bill, to find B. So I have my equation is P plus B plus, seeing that I'm running out of room, and let's just move it up even further there, and let's restart here. So my equation is P equals B plus B over 5. Okay, like that. But I know that P is equal to 36, so I can fill in 36 for P. Okay, and here I have an equation with fractions, and so I want to write these over 1, and then find the common denominator, which is 5. 1 times 1 times 1, 1 times 1 times 5. Okay, like that. In this case, that is the lowest common denominator too. So I want to convert each one of these to have a denominator of 5. All right, boy, this problem's going on a long time, isn't it? I got to make a lot of room. Okay, so I want each one of these terms to have a denominator of 5. Okay, notice that the last one is already over 5, so I don't have any work to do with that. All right, and so for that 36 over 1, its denominator right now is 1, but I want it to be 5, so I multiplied top and bottom times 5. Okay, 36 times 5, I don't know off the top of my head, so I can plug it in with that, and that's 180. I just did that on my calculator. All right, and then I have this B over 1, and I want its denominator to become 5, so I'm going to multiply top and bottom by 5. So I got B times 5 right there. Just remember I can rewrite that as 5B. That didn't come through very clear. Looks more like a 6, didn't it? All right. And so now, what's the deal is that I have all these fractions, but they all have the same denominator, and I have an equation. Remember, that's really important for being able to cross out these denominators. I have to have an equation, because what I'm really doing is multiplying by 5 on both sides, but all that does is cancel out the denominators. All right. And so I have 180 is equal to 5B plus B. Like that, 5B plus B, those are like terms. That's 6B. So to isolate the variable B, I would divide by 6, and 180 divided by 6 is 30. Okay, so remember, we don't want to stop there. So this was a word problem. It had wording, and so what would I say? I would say that the bill was $30. Okay? So you can see we've already done everything that I've talked about up to this part right here where we actually have to solve the equation. So we're only adding a small layer on, so hopefully this goes well for you. And the key thing is you want to just try to start getting comfortable with word problems as soon as you can, and try to avoid that very common thing that people do is they just try to get down to the heart of the matter, but but without any setup. And so then doing the actual calculations to get this answer becomes a lot more complicated. And see, that's the power of algebra. Once you get to this equation, you can answer any question you want about it, and all you have to do is just follow simple processes, and then it's a lot less likely that you'll get lost. Okay, so I hope that helps. Wish you the best.